Let's say you're out on a walk. You're walking along with our mystery quality man. You're just enjoying the fresh air and the sunshine. And you come across a vending machine. You realize you're a little hungry, and those Cheetos look pretty good. So, what do? You put in some money into the vending machine and you type in A1. A1. And out pops out some Cheetos. Alright, so you got some Cheetos. And now you realize while you're eating some Cheetos, you're a little thirsty. And so you look at that Pepsi, you put in some more money, and type in A2 for a Pepsi. And out of the vending machine pops out your Pepsi. So you're satisfied. You got some Cheetos, you got some Pepsi, you got exactly what you wanted. You typed in A1 and A2, and you got your Cheetos and Pepsi. But what if something else happened? What if you typed in A1 and out popped out some Skittles? You would be confused. You'd be like, whoa, I wanted some Cheetos, and I got some Skittles. That's not right. Well, okay, maybe trying with the Pepsi, maybe that'll work out. Well, you type in A2, and out pops out your Pepsi. However, out pops out some Skittles as well. You'd be like, what's with the Skittles? I just wanted Pepsi. This brings us to the idea of a function. So what we have on the left, this idea over here, that is what we want. We want to type in A1 and just get our Cheetos. We want to type in A2 and just get our Pepsi. We don't want any Skittles. So that is our idea of a function. You put something in. Here we were typing A1 or A2. You put something in, and you get one associated thing out. Our A1 up here is associated with Cheetos. It is not associated with Skittles. That is what our A3 up here is for. In the same way, our A2 is associated with Pepsi. It's not with Pepsi and Skittles, it's just Pepsi. So we're saying that our vending machine, if it worked like this on the left, it is a function. It's working properly. You put something in, and you get one associated thing out. It's important to think about how this word function gets used in real life. Function is used in real life. So if you're on, let's say, an elevator, and you push the number 3, you want to go to the 3rd floor, right? And if it takes you to the 3rd floor, you can say the elevator is functioning. Or in other words, we can say that our elevator is working properly. If you punched in that 3 and it took you to the 8th floor, well, the elevator's not functioning. It's not working properly because putting in that 3 is associated with taking you to the 3rd floor. You put something in and you get one associated thing out. And that's how our vending machine works. We put in our A1, we want to get our Cheetos out. We type in A2, we want to get our Pepsi out. And looks like no one wants Skittles, so we're not even going to worry about that. In a similar way, let's say you have a broken arm. You fell down and broke your arm, and you're going to the hospital now. You go to your doctor, and what do? They give you a cast to put around your arm. Your broken arm is associated with your doctor giving you a cast. If you show your doctor the broken arm and your doctor gives you some Skittles, you're going to be like, why am I seeing Skittles everywhere? And your doctor is not functioning. He's not working properly. Your broken arm is associated with a cast, and only a cast. So, now that we've kind of had an idea of what a function is, you put something in and you get one associated thing out. Let's see how this connects to Algebra 1. Let's say we have an equation, y equals negative 6x plus 2. And already we can tell that this is a linear equation because it is in the form y equals mx plus b. And let's go ahead and let's take a brief second to review. Let's graph this here. Let's plot this on our xy chart. Okay. Well, we know that we know our B stands for the y-intercept, so that's where our line crosses our y-axis, so we can go ahead and plot that at 2. So we have 1 point on our line is up here. And let's just pick another point, because we need 2 points to draw our line. So let's pick an x. Let's say if x equals 1, what does y equal? Okay, so we have our equation, y equals negative 6 times x, which is 1, plus 2. That's negative 6 plus 2, which is negative 4. Okay, so now we have one more point. We have x equals 1, and then we go down to negative 4. 1, 2, 3, 4. Okay, and so we can plot a point right here. Now we can draw our line. There's actually a second way we can get that point right there. If you notice, we used our y-intercept too, but we didn't use our second important piece that we have, which is our slope. We have our m. So what does this negative 6 say? That says when we increase x by 1, y goes down by 6. Y changes by negative 6. So if we knew our y-intercept up here at the top, we could have said, okay, when x increases by 1, y goes down by negative 6. And then we could have found this point right here. So that's an alternative way. We picked an x here, or we could have used our idea of a slope and a y-intercept. So now that's a little bit of a review. And my question to you is, now that we know the idea of a function where you put something in and you get one associated thing out, let's get rid of that red there. My question to you is y equals negative 6x plus 2 a function? Well, we picked an x and we got an associated y out of it. Couldn't we just keep doing that? We can. So yes, we do have a function here. We do have a function because each x is associated with one y. Pick any x. Even we can look at our graph. Let's travel from our center, and we travel down to an x. Pick any x. And this x right here is associated with one y. One y right there on the line. Similarly, let's pick a different x. Let's say we go left on our axis here, and we pick an x right here. Well, that x is associated, let's extend this. That is associated with one y right here. So each x is associated with one y. And that's our definition, right, of a function. You put something in, you get one associated thing out. We put in our x equals 1 here, we get a negative 4 out. And it's similar, we can bring out our example. Remember, we plugged in A1 and we got out some Cheetos. It's kind of a similar idea. With our equation, we put in an x, or for example, let's just say we put in A1, like in our vending machine, and we pop out some Cheetos. That's kind of the idea. You put something in, you get an associated thing out. However, in this case, we're working with numbers. We're not working with Cheetos. So you put in a 1 instead, and then you get out a -4. So that's the idea of a function. Put something in, you get associated thing out. And what's associating these things? It's this -6x plus 2, right? We plugged in the 1, and then do -6 times 1 plus 2, and then out pops the y. Okay, so now we've established that we have a function, and you might often see it stated like this. You might see y is a function of x. So I think it's a little easier to think about it the first way, just saying, is our equation here a function? Well, when you see it written like this, y is a function of x, it's the same idea. You're just saying you put in an x and you get one associated y out. So thinking about it that way, let's go back to our input, our sample of x we had here. We put in an x equals 1, and you can think of it sort of like a little machine. We have a little machine here, and I'll bring it down just a bit. This is a machine, and we put in our x equals 1, and we plug it into this -6x plus 2, and out popped out that -4. Right? That's what we did up here. We had our x equals 1, and then we put that in right there into our -6x plus 2, and then out popped the -4. This is the idea of a function. As we noted it down here, you put it in x, and you get an associated y out. So oftentimes this little machine here is just called the function, or f of x. That's the symbol that's used, f of x, so a function of x. And so we can just say oftentimes that f of x, this function, is equal to this -6x plus 2. So it might be a little confusing writing it like this. You might say, didn't we just say y is -6x plus 2? And we did, that's correct. But now we're saying y is a function. So we just replace the y with this f of x. And it's just another way to rewrite the equation, but now we're emphasizing that we're looking at a function. So you don't even have to think about it. Now that you know that y is a function, maybe you could just rewrite it like this, like as f of x, and so someone looking at it can immediately recognize that we have a function. And going back to our machine example, another way to think about it, as I mentioned, you input something into a machine and out pops that -4. Another way, and I think this might be a fun example, think about if you've gone to a pizza place where they make the pizza in front of you, what do? Well, you give them all the ingredients you want, they put into the oven, and out comes your pizza. That is the same idea. You can think of this input, our x equals 1, as that's our set of ingredients. And then we put it into our machine, our oven, and then out pops our pizza. And so, similar idea, it's a machine. Just like we had our vending machine, right? You put in that A1 into the machine, out comes out a Cheetos. And that machine is a function because we want those Cheetos. That is the associated thing with our A1 here. A1 is associated with Cheetos. Similarly, you put in your ingredients, put them into the oven, and you get your associated pizza out. that is the idea of a function. And so let's dig a little deeper into that f of x idea. You can rewrite the equation as f of x equals a negative 6x plus 2. And again, this is just a symbol. It's just a symbol that math people use just to recognize that we're looking at a function. So this, you could say, is a function of x, or pronounced often f of x. So we said up here, we put in our x equals 1, we popped out that negative 4. When we use our function notation here, how does that work? So let's say we put in x equals 1, and then that's our ingredient for our pizza. That's our ingredient. And then we put that into the oven, our function oven. We're putting that into the oven. Ingredient goes in the oven. F is our function. And then out pops out, putting that into our function. Remember, our function's up here. It's the same as saying y equals negative 6x plus 2, but we're just emphasizing that y is a function. So when we plug that into the equation, we get negative 6 times 1 plus 2, which again gives us our negative 4. So it's the same exact thing. I'm not introducing really anything new. All we're recognizing is that y is now a function, because each x is associated with one y. And so sometimes you'll see it graphed like this. Instead of x and y, you'll have it x and f of x. So instead of y there, we just replaced it with f of x just to emphasize that we have a function. So you would just plot this in the same way. If we have x equals 1, pops out a negative 4, well, we go right on our axis to 1, and we go down 4, and then we plot our point. And so when you have this phrase, this y is a function of x, it's the same as saying y equals f of x. Y is a function of x. So you can see it in two different ways. It can be easy to get this idea, a little confused, but just remember that we're just replacing y with f of x because we know it's a function. We're just rewriting it. So I definitely encourage you to maybe rewind and rewatch this example. There's a lot of information here. It's important to think about it like a vending machine or like a pizza oven. You put something in and something comes out. And if that's the case, if we have each x associated with one y, then we have a function. And we could rewrite it with this function notation. So, a little confusing. Take time to understand this example. And we will try another example. All right, we want to evaluate f of x equals 8x minus 3 when x equals 5. All right, evaluate the function. So just solve this function when x equals 5. Again, we're just looking at y equals 8x minus 3. It's in the form y equals mx plus b, so we know it's a linear equation. But as we noted, with a linear equation, each x is associated with one y, so we're just rewriting it with this function, with this f of x. So all it's saying is plug in x equals 5 into our function, into our equation, and see what pops out. Back to our pizza example, we have our ingredient x equals 5. It goes into our oven, where it gets 8x minus 3. This is our function oven, function machine, and we want to pop something out. So let's do that. Let's say we have f, and then we put our ingredients in, x equals 5, and then out pops out 8 times 5 minus 3. And then we get 40 minus 3, and that equals 37. And making a quick plot of that, we're saying we have our x's here, and our outputs, our f of x, which is same as y. And then we're saying when x equals 5, we go down the axis to 5, we output 37 on our axis here. 37 is here. So that's a point on the line. And if we want to find another point, let's go ahead and quickly plot another point. Within seconds, you can find another point. And why is that? Well, we know our y-intercept right there. We go down on our y-axis, or our f of x axis, to -3, and we know that that point is on the line. And we can quickly draw a line. And we know that the output of our function, when we evaluate it at 5, x equals 5, is 37. All right, another example. Does the graph represent a function? Okay, so a function, remember, we're saying that each x is associated with one y. That is our big takeaway here. Each x is associated with one y. You put in some ingredients, you get out your pizza, you put in your A1 up here, you get out your Cheetos. A1 is associated with Cheetos. And so we're going to look at some graphs and see if they represent a function. So our first graph we're going to take a look at is here. So does this graph represent a function? So can we say that each x is associated with one y? Let's pick some x's. Let's just see. We can use this graph to figure it out. Let's pick an x right here. And let's see our y. We pick an x here, and we're associated with this one y. We pick another x, and that's associated with one y. And you can keep picking x's. You can just go down this line and then keep picking x's and see that they're associated with one y. So yes, this is a function. Yes, each x is associated with one y. All right, let's try another graph. What about this graph here? Well, we do the same process. We pick some x's. We want to see, is each x here associated with one y? Okay, let's pick an x. That x right there, that is associated with this y right here. This x, that goes to 1y. Okay, we're good so far. Let's keep picking x's. That x right there is associated with y here. We keep on going, and it looks like every x that we're trying is associated with one y. So we can kind of say the same thing. We can say, yes, this is a function, because each x is associated with one y. All right then, let's try another graph. How about this guy right here? Same process. Is each x associated with one y? Let's pick some x's. Here's an x. Well, that x is associated with a y there, but it's also associated with a y down here. So this is not a function. This x right here, we found an x that has a y as a y up here and a y down here. That's the same as our example from the very beginning. Remember we said right here, when we put in A2, we want a Pepsi. We don't want a Pepsi and Skittles, and that's kind of what our graph over here is saying. That's saying that we put in our A2 and we're getting a Pepsi up here and Skittles down here. We're getting two things, and that's not what we want. And you can see that you can keep finding more points. You can keep finding more points where that's the case. Here's an X, and that's associated with one Y here and another Y here. So we only need to find one example, really, where you get Pepsi and Skittles. And that's enough to say that we don't have a function, because each X has to be associated with one Y. So our answer, no, it is not a function. And as we marked on the graph, we can find an X that is associated with more than one Y. More than one Y. We found an X right over here, and we found our Pepsi and our Skittles. We found more than one Y. So in other terms, we can say that Y is not a function of X. That's another way of saying it. We saw in our examples up here that these are functions, so we can say Y is a function of X. Y is a function of X. But now we're seeing that Y is not a function of X. Let's try another one. We have plenty of examples in this video. All right, we have another graph. It's kind of like a little puzzle. Can you find an X where you get Pepsi and Skittles? So let's pick an X. Let's pick one X and see. Okay, we got associated one Y. Okay, let's try it again. Let's pick an X here. Okay, that's associated with a Y here. All right, let's try a few more points. Try a few more. Okay, that point here associated with a 1Y. Here, associated with 1Y. We keep seeing that each X here is associated with 1Y. So it looks like we have a function. We can't find any example where we get Pepsi and Skittles, where we get two Ys. So we can bring down our answer. And you'll get the same answer every time, because a function has just one definition. We have each X associated with one Y. So we say Y equals f of X. And let's try one final example. We have another graph. Okay. Again, let's look at X's, see if we can find any where they have more than one Y. So this X is associated with a Y here, but also a Y up here, and up here. And it's the Y down here, and a Y. So this X is associated with a lot of Ys. So we don't even need to look for another example, but you can see if you pick other X's that they are associated with more than one Y here. More than one Y on this green graph, this green line. So we can say our same thing, our no from up here. We can say the exact same thing. As we marked on the graph, we can find an X that is associated with more than one Y. We have an X here, and similar with our Pepsi and Skittles idea, we found an X here. We punched an A2 on our vending machine, and what happened? Well, we got some Skittles up here, and Skittles here, and Pepsi, and Cheetos, and we got all kinds of weird stuff. So we got a bunch of weird things here. So our a2 is associated with a bunch of different things. So we can say that y is not a function of x. We put it in x and we could get several y, several things out of the vending machine. That is not what we want. You put in your ingredients into the oven, you want to get your pizza. You don't want to get 5 different pizzas, right? So that's the idea. So there was a lot of information in our video here today. We did several examples. We worked through what a function is, just saying you put something in and you get one associated thing out. Or in the idea of algebra 1, each x is associated with 1y. So I encourage you to review, especially this example here, with our oven, our ingredients, and our ingredients going into the oven, popping out a pizza. This is a really important example because it introduces the function notation. So take some time, review, and just remember our vending machine or our pizza. Think of it like a real world example, and you'll get the concept.